All right, this is lesson 2.5, comparing and ordering decimals, fractions, and percents. So the first thing we're going to start with is ordering just fractions, comparing and ordering fractions. You need to know how to compare a couple fractions and order fractions, okay? Sometimes you might have like a fraction, a percent, a decimal. You might have the different things, and then you'll want to convert them all to be the same, and then you'll be able to compare them and order them. We'll get to that on the next board. But let's just take fractions and order and compare them. So comparing this, I have 2/3 and 4/9. The key here, there's two ways to do it. First way is you want to have the same denominator, okay? So I look at these two, I have 3 and 9. I take my biggest denominator, 9, and I try and find the number that 3 will go into. Will it go into 9? Yes. So I can go like this. 3 times 3 equals 9. Do the same to the top. 2 times 3 is 6. So now I have 6 9s and 4 9s. Now, 9 makes up my whole. And I can compare them because they're the same. They're both 9s. It's like I have a pizza with 9 slices over here and a whole pizza with 9 slices. I'm going to see which one did I eat the most of. I ate 6 slices over here. I ate 4 slices over here. The pizza is both 9, the same whole. Now, is 6 greater than 4? Yes. So it goes like that. And I can do that once I get the same denominator. All right. There is another way to do this. If you don't want to get the same denominator, what you're going to do is you're going to cross. You start here, go across, multiply these together. 3 times 4 is 12. Put that right there in the corner. Then go this way. 9 times 2 is 18. Okay? And you got to start at the bottom and go up. You always go this way and that way. You got to go up. Denominator to numerator crossways. 3 times 4 is 12. 9 times 2 is 18. Then you look at these two numbers. Which one's greater, 18 or 12? We know 18 is greater. So it goes like that. Okay? That's another method. So you either find the same denominator and get everything in to be the same denominator, and then you compare the numerators. Which one did you have more parts of the whole? Or you can cross. Okay? Now, sometimes you're going to have 4 different fractions, and you need to put these in order. This one says from least to greatest, so smallest to biggest. I want to find the smallest one here. Now, they all have a different denominator, so I can't really compare them, the numerators, until they have the same denominator. So what I'm going to do is I'm going to start with the biggest denominator, which is 6. I start with 6, and I ask myself, does everything go into 6? If everything goes into 6, we have the common denominator. 2 goes in, yep. 6 goes in, 3 goes in, 5 does not. If only 1 doesn't work, it doesn't work at all. So, can't be 6, I'm going to go next higher. 12. Yes, 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 no. Got to go the next higher. 6, 12, and then 18. Yes, 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 no. Okay? 24. Yes, 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 no. Next one is 30. Yes, 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 yes. So 30 is my common denominator for all 4 of these numbers. So then I erase these because I know 30 is my number. 30, 30, 30, 30. So the way I get this 1/2 to be something over 30 is I go from this to this. 2 times 15 equals 30. 1 times 15 is 15. 6 times 5, so I got to do 5 times 5, 25. 3 times 10, so 2 times 10 is 20. 5 times 6, so 3 times 6 is 18. All right. So these are all the same. This is the same as this. This is the same as this. Same, 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 same. But they all have the common denominator now. Easy for me to compare. Okay? I'm going to say like the whole is this 30. So 30 makes up, I'll make it into dollars. So I have $30. That's my whole, 30. If I spend 15 of those dollars, how does that compare to if I have $30 and I spend 25? Well, I've spent more here. Okay? So I can easily just compare these numerators. Which one's the smallest? 15, 25, 20, 18. 15 is the smallest. So I go from least. And then the next biggest, after I have 15, then a little bit more would be 18. Then a little bit more of that would be 20. Then a little bit more than that would be 25. Oops, 30. Okay. So 15 over 30, 18 over 30, 20 over 30, 25 over 30. I'm getting bigger and bigger. I'm getting closer to spending the whole thing, all of it. Okay? But when someone says order these from least to greatest, it doesn't mean change them and then order them. It means order these exact ones. So I know 15/30 is the same as 1/2, so it's going to be 1/2. 18/30 is this one, so I come over here and it's 3/5. 20/30 is this one, so it's 2/3. And then the last one is this one, 5/6. There you go. Now, this is my answer. I've ordered them least to greatest. But I had to take them to the greatest common denominator, then I ordered them, then I took them back to what they originally started as. Okay, so that is comparing and ordering fractions. Let's go over here, and we're going to talk about not ordering, we're going to talk about comparing. Comparing decimals, fractions, percents. Now, you've heard of the expression apples to apples, or I can't compare apples and oranges. Apples and oranges are two different things. I can't compare them. You need to make sure you get them to the same thing. Once they're the same, I can compare this apple with this apple. I can compare this car to this car. But if they're different, I can't compare them the same way. So, we just spent 4 lessons learning how to take a fraction to a percent to a decimal to a fraction, and back and forth and back and forth. So you have to decide, and you can do this many ways. What do I want? Okay? On this one, I'm going to get it to both be a fraction. Okay? So I want to make this into a fraction. 0.6, I know if I say it, it's 6/10. So it's 6/10. Okay? And this is 2/3. Now I just have to get it to a common denominator. 3 and 10, I know that 30 would work for this. 3 times 10 is 30. 2 times 10 is 20. 10 times 3 is 30. 6 times 3 is 18. So now I have 20 over 30, and I have 18 over 30. I know 20 is greater, so it's going to go like that. Okay. The other way I could do it is do cross. 3 times 6 is 18. 10 times 2 is 20. 20 is greater, so I know it goes this way. All right. So I know, based on getting it to the same, I know that 2/3 is greater than 0.6. The other way I could have done this is divided this. If you would divide this to make it into a decimal, 2 divided by 3 gives you 0.6666. And then you can compare that. These are the same. They have 0 here. I have 6 here. This one has a little bit more, so it's going to be greater. Okay? This one, 7% to 7/10. I could get this to be a percent, and by doing that, I have to take it to a decimal. Once it's in a decimal, I can make it a percent. So 7/10 is 0.7, And if I want to make that a decimal or a percent, I go 1, 2, and then I put my percent there. Then I put a 0 here, get rid of this tail, and I have 70%. I converted this to a percent, 70%. Is 7% greater or less than 70%? Well, if I'm taking a test and I get 7% compared to 70%, I have done a lot less on this side here. Okay? Or I get 7% of my job done. I just get a little bit done compared to 70% of it done. A lot of it done. Almost 100%. The other way I could do is I could make this into a fraction. We know that this into a fraction, well, let's make it into a decimal. We know that's 0.7. This one, 7%, going this way gets it to a percent. So here's my decimal. I got to take this and go away. 1, 2. Put my 0 there. Then I get rid of this. And I have 0.07. 0.07 compared to 0.7. This is a lot smaller. I can always add a 0 on the end of that. And if I think about money, I have 7 cents here. I have 70 cents here. That is greater. This is less. The other thing I could do is take it to a fraction. 7%. The way to get rid of the percent is put it under over 100. 7 hundredths compared to 7 tenths. Then I just have to get this to be the same as this. Get it to be 100 times 10 times 10. That's 70. So I have 7 over 100 compared to 70 over 100. That's greater. Okay? See, I'm doing it on my time. Okay, just a couple more minutes. This is the last one I want to compare. You can see how I took this to all 3 different things. 6.5 compared to 650. If I'm guessing, I'm going to say this 650% is a lot bigger. It's a huge number compared to the 6.5, which seems so small. But I'm not comparing the same things. I want to get this to be a decimal so I can compare it. So 650%. To get rid of this, I got to start at the decimal and go 2 over. 1, 2. And then I can get rid of this. Okay. 6.50. 6.5. I could add a 0 right here because I can always do that. 6 is the same. 0.5 is the same. 0 is the same. They're the same. Okay? So, taking this to a decimal, but what if I took this to a percent? 6.5. I want to take this to a percent, so I got to go 1, 2, then I make my percent, add my 0 there, get rid of the tail, 650%. So 6.5 is 650%. Now that I have a percent and a percent, the same things, I compare them. 650% is the same as 650%, so they are equal. Okay? You always want to get it to be the same, and then it's so much easier. You're able to compare them. Okay? Go ahead and watch the guided practice. Try some independent practice. If you have any questions, let me know.